Welcome back, students. So now we'll be learning about address resolution protocol. Okay, if a node has to send a datagram to another node through one link, so we know that it has to have that IP address of the next to whom it has to send. Okay, that any time a node has an IP datagram to send to another node in a link, it has the IP address of the receiving node. The source host knows the IP address of the default router. Each router except the last one in the path gets the IP address of the next router by using its forwarding table. The last router knows the IP address of the destination host, right? However, the IP address of the next node is not helpful in moving a frame through a link. We need the link layer address of the next node. This is the time when address resolution protocol becomes helpful. Okay, so that is called, in short, it is called as ARP. Okay, whenever we need to send one datagram to another node, only the last router will be knowing that destination, but before that how we are going to send, there we have to go for a one more address resolution protocol. The address resolution protocol is one of the auxiliary protocol defined in the network layer. It belongs to the network layer. It maps an IP address to a logical link address. ARP accepts an IP address from the IP protocol, maps the address to the corresponding link layer address and passes it to the data link layer. So let us see what is the position of the ARP in the TCP/IP protocol suite. So if you see here, and the data link layer, so if we have the IP address, and then from through the IP address, through the ARP, we are connecting it to the link layer address. So position of ARP in the TCP/IP protocol suite. Okay, so anytime a host or a router needs to find the link layer address of another host or router in its network, it sends an ARP request packet. So it will send an request, okay, telling that you need to, I should know to whom I have to send this. This packet includes the link layer and IP address of the sender and the IP address of the receiver. Because the sender does not know the link layer address of the receiver, the query is broadcast over the link using the link layer broadcast. Okay, so let us see what is the ARP operation here. Okay, so here there is a system A, then there is a system B. Okay, then we have to see how this how it is going to check. Now we have two routers here. Okay, so then the network, whatever the system A has to communicate to system B, means it is going to send a request. Now through which router or through which link I am supposed to, through whom I have to go through. Okay, so there now every host or router on the network receives and processes the ARP request packet, but only the intended recipient recognizes its IP address and sends back an ARP response packet. So once the request is passed, it is broadcasted all over, then that particular recipient, it will recognize its IP address and then it will communicate or telling that, yeah, this is my address, you can send to this address. The response packet contains the recipient's IP and link layer address. The packet is unicast directly to the node that sent the request packet. Now here in this figure, the system on the left, that is system here, has a packet that needs to be system delivered to system B with IP address N2. Okay, system A needs to pass the packet to its data link layer for the actual delivery, but it does not know the physical address of the recipient. It uses the services of ARP by asking the ARP protocol to send a broadcast ARP request to ask for the physical address of a system with an IP address of N2. This packet is received by every system on the physical network, but only system B will answer it as shown in figure B. So this will be answered by system B. Now in here, system B sends an ARP reply packet that includes its physical address. It will include its physical. Now system A can send all the packets it has for its destination using the physical address it received. Okay. Now let us see what is caching. Okay, so let us assume there are 20 systems connected to a network, system A, system B and 18 other system. Okay, we also assume that system A has 10 datagram to send to system B in 1 second. Okay, now first option is without using ARP. System A needs to send 10 broadcast frames. Okay, each of 18 other system need to receive the frame, decapsulate the frame, remove the datagram and pass it to their network layer to find out the datagram to to whom it belonged to. This means that processing and discarding means 180 broadcast frames, right? So each particular frames being systems has to do this encapsulation decapsulation process. But if we use ARP, what happens? System A needs to send only one broadcast frame. Each of the 18 other system need to receive the frame, decapsulate the frame, remove the ARP message and pass the message to the ARP protocol to find the frame that the frame must be discarded. This means that processing and discarding only 18 instead of 180 broadcast streams. After system B responds with its own data link address, system A can store the link layer address in its cache memory. The rest of the named frames are only unicast. Since processing broadcast frames is expensive, time consuming, the first method is preferable. Okay, now let us see the packet format. Okay, so the hardware type field defines the type of the link layer protocol. Ethernet gives the type 1. The protocol type field defines the network layer protocol, that is IPv4 protocol is 0x0800. Okay, the source hardware and source protocol address are variable length fields defining the link layer and network layer address of the sender. The destination hardware address and destination protocol address fields define the receiver link layer and network link layer address. Okay, so that's all about address resolution protocol. So next we'll be seeing about the data link services with the more appropriate protocols, each on flow control. Okay, so we'll come up with the next session.